Great. Excellent. Thank you very much. Well, it's really a pleasure to be here. And I think many of you know that I have a passion for Mars. I'm the proud papa of Mars Perseverance when I was associate administrator. But I've had a long history with the Mars Society. And on my first Hubble mission, I actually flew a red, green, blue flag, which Robert Zubrin has, that his wife sewed when the Society was still very young. And so we flew the first Mars Society flag in space. Now, it didn't make it very far on its way to Mars. We were only up about 600 kilometers, but it's a first step. And, you know, now that we're in Zoom world, you get a little bit more of an experience watching on a screen, interacting with your friends, sometimes your family, and your colleagues, and going to meetings vicariously through the computer. And of course, you know, that's how we operate in space and have for many years. It'll be different when you're on Mars, of course. The time delay, you know, will make even virtual meetings like this virtually impossible. In fact, literally impossible. So we should all feel lucky that we're able to stay safe, COVID-free. COVID in space would be no fun. And that we're able to interact the way we can. What I'd like to do tonight, and what Robert had asked me to do, because we are celebrating the 30th anniversary year of the Hubble Space Telescope in space, which is pretty remarkable when you think about it. And so I want to tell you a little bit of that story. I'm going to try and share my screen with you. So if all goes well, you should be seeing a title slide that says Hubble.
Yeah, we can see it, John.
Excellent. So as I said, we're celebrating the 30th anniversary of the Hubble Space Telescope on orbit. And we have this image that is of a nebula of gas and dust, actually in quite far away from us, that is called Cosmic Reef. And it's, you know, really just a pretty image, but it shows two different environments in space, one of which, the very colorful red one, is a stellar nursery where baby stars are being born. And in fact, not only are stars being born as the gas and dust collapses and fusion turns on, creating new stars, but what we've learned from the Hubble and other observatories is that at the same time that those stars are formed, the protoplanetary nebula, and in fact solar systems, form at the same time. And so this is our birthday image for Hubble. Now, we've come a long way in astronomy from Galileo's telescope, and this is actually an image on the aft flight deck of Space Shuttle Atlantis with a replica of Galileo's telescope, and it was made with this glass from the same Italian glass factory, leather from theoretically the same herd of cows, at least in the same field as Galileo had access to, wood from the same grove of trees that it was carved from. And this replica, you know, as a period telescope, is about as accurate as we can do to replicate what Galileo must have used to observe the heavens. Now, he didn't invent the telescope. He used it to look at the skies and make those first observations. And what I can tell you about Galileo is he was a very patient observer because that telescope was a really lousy telescope. You really had to be very patient to figure things out. Well, that was only hundreds of years ago, and behind that telescope out in the payload bay is the Hubble Space Telescope. The Hubble Space Telescope isn't that much bigger. It is quite a bit bigger, but not ridiculously big. It's about the size of a school bus, and it has a 2.4 meter primary optic compared to about a 1 centimeter optic of Galileo's telescope. And it's that large size, the fact that it's above the Earth's atmosphere, so instead of stars twinkling, they're steady, and also above the Earth's atmosphere, it gets to see ultraviolet light and infrared light that doesn't make it to the surface. And that's what makes Hubble such a great telescope. However, Hubble didn't start out as a great telescope. For those of you who are old enough to remember when it was launched in 1990, Hubble was actually the butt of jokes of late night talk show hosts, of newspaper op-eds, of senators, of the American people. And so here's one of those cartoons showing a picture of the moon that looks like some kind of peanut, Jupiter, very distorted, Saturn, and then in the lower right, very angry taxpayers. Fortunately, we were able to go up to the telescope actually 5 times with the space shuttle, with women and men, to go and repair the telescope doing spacewalks. The most recent mission, which wasn't that recent, 11 years ago, was STS-125 on Atlantis, and this was and is the last mission to go up on the space shuttle, and we had quite a varied crew. In the center is Scott Altman, our commander. He appeared in the movie Top Gun. He actually flew the Tomcat, not Tom Cruise, and a whole bunch of others. This was my 5th mission to space and my 3rd mission to upgrade and repair the Hubble Space Telescope. And I just feel incredibly lucky to be able to have gone up on the space shuttle 5 times. And I can tell you it's really a rough ride. Trying to get off of planet Earth takes an enormous amount of energy, and it's basically a controlled explosion. And you hope that it's not a real explosion. But amazingly, 8.5 minutes after launch from the surface of Earth, in this case, Florida, 8.5 minutes later, we're in orbit, traveling 17,500 miles an hour, and in our case, at about 600 kilometers altitude, 350 miles or so. And at that point, we had to fly the space shuttle up underneath the Hubble Space Telescope. This is a picture of Scott flying the space shuttle to acquire Hubble. And then Megan MacArthur, our robotic arm operator, on her first flight, had to reach out and grab the Hubble. And I can tell you she's one cool woman. She's cool anyway, but she's really cool because she had never flown in space before, and she had never operated a robotic arm before because, after all, in 2009, we didn't train with real simulators. We had computer games to train with. And so she'd only virtually flown the arm in simulations and never actually flown it for real. And if she hit the Hubble or missed the Hubble, we wouldn't be talking now because there would be no Hubble Space Telescope anymore. But she did a great job, grabbed Hubble on her first shot. She had to. And so we could put it into the payload bay. And that allowed us as spacewalkers to get into our spacesuits, keeping in mind that these are cloth spacesuits, multiple layers, 11 layers of rubberized Dacron and other materials. And these are just incredible spaceships. And this is what I absolutely love about space, is getting into my own spacesuit, going outside. And it really explains what people have told me for years, including the Mars Society founder, Robert Zubrin, when he would say, "John, do you work in a vacuum?" And in fact, I do, and really love it. I don't know if you can see it, but I have a huge smile on my face. You can see the Earth reflected in my visor. In the backpack, we have oxygen. We have water, which is used for cooling. We have an emergency oxygen pack, batteries, lithium hydroxide, which is a scrubber for carbon dioxide. It reacts with water and carbon dioxide. We have lights, high and low beams, cameras, and all of our tools. And of course, the tools have to be tethered or you can lose them. In the back of the picture, you can see the wing of Space Shuttle Atlantis with that carbon leading edge and all of the equipment that we brought up with us and covered in gold Kapton. The Hubble Space Telescope is about the size of a small school bus or a bus. You can see the size compared to me. I'm on the left there with the red stripe on my suit. I was the lead spacewalker. And Drew Feustel, an exploration geologist, is riding the robotic arm. Megan is driving him around. And we use that arm to be able to hold heavy objects like the instruments and maneuver around the payload bay. Our prime task this day was to take out the old camera, wide field camera, which is the one that takes great pictures of the cosmos, and put in a super duper new camera, the Wide Field Camera 3. Not very creative names, but the Wide Field Camera 3 really is a state-of-the-art digital camera with a very large format charge couple device CCD that can take incredibly deep pictures of the universe and beautiful color pictures like the one I showed you, but also an infrared channel that allows you to see into those nebula and to much further back in the galaxies, in the universe, to see the most distant galaxies. We changed out a number of other instruments on this mission. We took out the first corrective optics instrument that was used to fix the aberration in the mirror that caused those fuzzy images, and put in a new ultraviolet instrument, and a new fine guidance sensor and new gyros. A lot of equipment that has allowed Hubble now, 11 years later, to still be fully operational. This is the longest it's gone without a servicing call, and everything is working, and the science that's coming out is still just really incredible. Let me spool through. So after 5 spacewalks, I got to do 3. Mike Massimino and Mike Good each got to do 2, and they also did repairs. We were able to release the Hubble Space Telescope, again on the robotic arm, and send it on its way for its mission of discovery. Now, we gave it a 5-year warranty, labor included, but of course in 2011, just 2 years later, Atlantis flew its last flight, and we retired the space shuttle fleet so that we could then move on to exploration class vehicles, the Orion and the Space Launch System. Of course, we're still waiting for the Orion and the Space Launch System, but that's a whole nother topic. But here is Hubble floating off over planet Earth with the aperture door open, and it's been observing ever since and doing great science. So what kind of science? As this fills the screen, this is an example of what that super duper wide field camera 3 can do. This is called the ultra deep field, or the extreme deep field. The Hubble deep fields are views of the universe that are extreme time exposures, where we went and we looked somewhere that we could see through our galaxy into a place that, if you were to look up in the sky, would appear very dark. And in fact, if you were to hold your pinky at arm's length, it's an area of the sky smaller than your fingernail. It's like looking through a soda straw. And with Hubble, when we look at that very dark part of the sky for a long period of time, the dim galaxies start to come into view. And if you look long enough, say for about 11 days or so, you can fill the sky with galaxies, because there's just galaxy upon galaxy upon galaxy looking deeper and deeper into the universe. In fact, Hubble has such sensitivity, even though it's a small telescope, that we've been able to see back in time, because of course light travels at a finite speed, over 13 billion years, and the universe is only 13.7 billion years old. So we're able to see back to some of the earliest galaxies in the universe. Virtually everything you see in this image, except for a bright star in the lower right that has the crosses on it, everything there is a galaxy, and there are over 10,000 galaxies there. So if you look at this image, and best is to go and download it from hubblesite.org, HUBBLESITE. I'll have the link at the end. But if you go and you look and you expand it and you see some little pixel that's red, bright pixel, you know, that's a galaxy with 50 billion stars. A little bit closer to home, we're getting into winter, and soon you'll be able to see the Orion Nebula at a reasonable hour, like now, in the night sky. And in the Orion constellation, we have the belt and we have the sword, and the middle star in the sword is actually not a star at all, but this incredibly rich nebula of gas and dust that's, again, a star-forming region. It's relatively close to us. And inside of this nebula, you know, hundreds of baby stars have just turned on, and they're lighting up the nebula from within. And we're able to study the whole 3D structure of this. And this is probably what the Earth and our sun and our solar system looked like around 5 billion years ago, as our sun was finally coalescing to form our solar system, to form, you know, the Earth, to form Mars and the rest of the planets. The other thing about this image, for me anyway, is it shows that what Hubble has told us about our universe is that it's not just a bunch of points of light. It's a rich and varied artistic fabric of beautiful things. And who knew, you know, before we had the Hubble Space Telescope. Now, of course, this is Mars society. And one of the things that Hubble has been really good at is looking at Mars. Now, I've been going out with my 5-inch telescope, my Celestron C5, night after night looking at Mars, because it's so close to us and so bright. But I live in Boulder, Colorado now, up in the mountains, and I had this fantasy about doing a lot of amateur astronomy, but we've had these incredible fires as well. And so the smoky sky has really limited what we've been able to do. But the Hubble Space Telescope is above all of that. And so it gets these amazing pictures. And again, this is a time-lapse photo, and it's taken, one at a time over a series of hours. And we can see Phobos as that in each of these images as we stack up on Mars. But what we can also see is what you all know, of course, is that Mars is a lot like Earth. Of course, it's a rocky planet, but we can see that it has, a north polar cloud cover and north polar ice. We can see a south polar cloud cover, which is a carbon dioxide water cloud. And then on the right side, we can see water ice clouds up in the atmosphere. And so we know that there's water on Mars. You keep seeing these discoveries of water on Mars, and we've known that there's water on Mars, certainly since the 1950s, if not before. And so Hubble has been actually able to study, meteorology on Mars, climatology on Mars, by looking at Mars repeatedly, and these are opposition photos. Of course, there's one from 2018, more recent one from even more recent than that. But we can see the expansion and contraction of polar caps. We can see clouds. We can see dust storms. We can see all kinds of things. Of course, we have many spacecraft at Mars right now. And so, it's easier to look in detail at Mars, but Hubble is still giving us great data and looking there. Here's an example of looking, just over a few months at a global dust storm, encompassing all of Mars from the Hubble Space Telescope. Well, what about the future? Eventually we are going to be flying SLS and Orion. And, if I were king, one of the missions that I would do with the Hubble Space Telescope is go back and with the Orion system, is go back and service the Hubble Space Telescope. And it's really uniquely suited to do that because you can co-manifest all the equipment you need on the SLS, launch the Orion to orbit. And Orion was designed to spend a few weeks in space. You might have to add a robotic arm, but it's a totally viable thing to do, in my opinion. And you may remember in 2004 that NASA announced it was not going to service the Hubble Space Telescope again. And, I was upset. Many people were upset. And one of the groups that came to the rescue of Hubble and published editorials and commentary was the Mars Society, saying, why do we explore? Well, we explore to do things like upgrade and repair the Hubble Space Telescope, that's worth risking astronauts' lives for. And that's something that I talked about. I said I would be willing to risk my life to do it again. And many other astronauts felt the same. And I feel the same way about space exploration in general. Humans have a unique role, not only the manifest destiny of humans going to Mars, eventually establishing, some kind of, permanent habitation on Mars. But we should only do that. We should only take risks in space exploration, if it's worth risking our lives for. And I think Mars exploration is one of those things that's worth risking our lives for. I would certainly go. Now, that previous slide was the future question mark. This is the future for sure. We are going to launch the James Webb Space Telescope. It's an infrared telescope. And rather than this puny 2.4 meter mirror, it has a 6.5 meter optic segmented. And it's going to be phenomenal for exploring our solar system, exploring our galaxy, and seeing the farthest galaxies and maybe the earliest stars in our universe. It launches next year, and I'm really excited about that. Please stay tuned. It's going to be phenomenal. So with that, I want to leave time for questions. The Hubble story is still very much alive. And if you want to see all of the images that I showed, you can find them on nasa.gov or hubblesite.org. And with that, I'm happy to take questions.
Thank you, Dr. Grunsfeld. That was excellent. You actually already answered one of the questions that was presented about whether there was a method potentially to continue to service the Hubble Space Telescope. The other question that was associated with that is what is the service life right now for the Hubble Space Telescope?
Well, so the question of how long can Hubble last is a good one, and nobody knows. And this is relevant for Mars exploration because we need to build things that are super reliable and repairable, right? If we know something's going to wear out, that's okay if we plan for it to be repairable, and especially if it's modular. I'm a big advocate for building our Mars spaceship, our first Mars spaceships, in fact, all Mars spaceships, very modular so they can be repaired, either by robots, if it's a purely robotic mission, or by people, if people are there. And so that was the great thing about the Hubble Space Telescope is it was designed to be serviced. It was very modular. And one of the Achilles heels on Hubble, if you will, or things that we know wear out, are the gyroscopes. And they allow you to accurately point the telescope to acquire targets. And in 2009, we put a full complement of 6 gyroscopes on board. And we need 3 to do top-level science. 2, we can still do good science. And with only 1 gyro or no gyros, it limits the science we can do. And right now we have 3 working ones and 3 failed ones. And so that's in 11 years. So we hope that we might be able to get another 5 or 10 years out of the Hubble Space Telescope, but that presumes no other failures. And Hubble has now gone for 9 years, and what we hope is that all of the infant mortality, if you will, of the hardware, all of the early failures have already happened, and we fixed everything so that it can last a long time. The batteries are in great shape, the instruments are doing well, the solar arrays, the power system, so far everything's doing well. And for most things on Hubble, not everything, but we have 2 systems, an A and a B, and we can even cross-strap them. So if an A circuit on one system is working and a B on another, we can still keep operating. So even as we have failures, Hubble will, as we say, degrade elegantly and should keep operating. I think the really exciting thing will be when we have Hubble and James Webb Space Telescope up at the same time, and if all goes well, the Nancy Grace Roman Telescope at the same time will really be able to kill astronomy in a good way with all of these capabilities at once by seeing new things we've never seen before and be able to follow up with one observatory or another, or observatories on the ground like the big 30-meter telescopes or the Atacama Large Millimeter Array radio telescopes on the ground, and be able to follow up on new discoveries. I like to say that the most amazing discovery from Hubble hasn't happened yet.
Excellent. It would be wonderful if we could all degrade so elegantly. Nickel asks about the requirements for becoming an astronaut, and in particular, as a Filipino citizen living in the Philippines, is there a chance that he could become an astronaut in NASA?
Well, probably not a NASA astronaut, because NASA astronauts are all U.S. citizens. Now, if he moves to the U.S. and gets citizenship, then that's an opportunity. And we've had a number of astronauts who came from other countries, lived in the U.S., were doing science or doing engineering, got their U.S. citizenship, applied, and have flown in space. But the world is changing really fast, and we're seeing countries all around the world start their own space programs. And so if the Philippines starts a Philippine space program and joins a collaboration with space programs that have human space flight, you could be a Filipino astronaut.
Cool. Holger asks, how is the effect of living under a complete black sky for those weeks in space, or isn't it noticeable due to the lack of opportunity to look outside the window? So I think he's asking, how does that affect your perception being under a night sky continually? Well,
when we orbit the Earth, for a mission like Hubble, we're in about a 96-minute orbit around the Earth. And typically, that's split up about a little over an hour in daylight, and then 36 minutes in darkness. And so actually for me as an astronomer, the challenge is there's not enough darkness because it takes about 30 minutes for our eyes to fully dark adapt. And the view out the window is really fantastic of the night sky. The Milky Way is so easy to see. you really can see the color of stars much more distinctly than you can on Earth, because they're not twinkling, so they're actually more of a point source, and they put more photons into your retina, onto the individual elements in the cones, so you can really see the colors much more brightly and distinctly. But then the sun comes up and it ruins it all, and you move on. But I think on a trip to Mars, where you're spending 8 months in cruise, and you have the opportunity truly to have a night sky, I think that's where folks who either are astronomers or love astronomy are really going to love it, because they'll be able to spend hours looking at really dim things. And of course, we're going to have to bring small telescopes to enable, astronauts to look at the night sky. And it's going to be one of those hobbies that's really important, because after a couple of weeks, the Earth is just going to be a blue dot, and Mars is going to be a red dot until 2 weeks out. So you got to look at something. So I think that's really exciting to me.
That's great. Thank you for sharing that rare perspective. I think we have time for just one more question here. Priyanka asks, what are the hurdles that came while installing the Hubble system?
Priyanka, that's a great question, because we trained over and over again to work on these instruments and put them in. For every hour in the spacesuit, I spent about 12 to 15 hours practicing in the big spacesuit underwater, simulating putting the instruments in, and then probably 5 times that working with simulators of high fidelity simulators of the instruments on the ground at the Goddard Space Flight Center, practicing all the things that could go wrong. And I would say that, virtually anything that could go wrong did go wrong. Screws that wouldn't come out and that got broken, wire meshes that we had to cut through that didn't cut properly, bolts that got stuck, you name it, and it happened. But because we had spent so much time thinking about what could go wrong and finding solutions before we even left planet Earth, once we got to orbit, it sort of seemed normal that things were going wrong, because we already had the solutions and we could fix it. The one problem that really was difficult was that Mike Massimino and Mike Good were out, and one of the bolts got stripped. The head got stripped, so that when Mike put the tool in, he couldn't take the bolt out. And that particular bolt was supposed to be so easy to take out. We didn't think of what would happen if it got stripped. And so we were really stuck. And, for over 4 hours, we were talking to the ground and trying to come up with solutions. And finally, somebody on the ground said, I wonder if Mike Massimino can just break off the handrail. It was held on with 4 bolts, and 3 of them came out, and one of them was stuck. And so he could sort of move the handrail back and forth. And they said, well, it would take about 60 pounds of force to break it off. And I think if they had said it was 200 pounds, at that point, Mike Massimino was going to get that handle off. And in fact, he did. He was able to pull it and break it off. And we were able to repair a really important instrument on the Hubble. But we had lots of hurdles out doing the spacewalks.
That's
Thanks.
great. Yeah, it sounds like Murphy's Law doesn't have an altitude limit.
That's right.
Thank you very much, Dr. Grunsfeld. We really appreciate your comments and perspective. And thank you for answering those questions.
Sure. Live long and prosper. And let's get to Mars.